Welcome to today's designTimber webinar. In a moment, I'll be handing over to the design team behind the Armadillo, we'll be finding all about this fascinating acoustic pavilion. But just before that, I'm going to tell you a few things about Timber Development UK. We were formed in 2021 from the merger of the two largest organisations in the timber supply chain, the TTF and TRADA. This means that as one body, we span everything from sawmill to specifier and all points in between, including architects, engineers, specifiers, sawmills, suppliers, you name it. Here are our three missions: to connect the supply chain, lead best practice, and to accelerate a low carbon future. And we go about this mission via webinars like this one, but also via our extensive publications and knowledge library. Here's a few examples from it. You can see designTimber. That's one of our two flagship member magazines. We have designTimber and supplyingTimber. TDUK members get a beautiful print copy of those magazines sent to them. But you can also read that magazine, the latest issue of which is just out, by going to the TDUK webpage. You can also see an example from our knowledge library there. There's a fantastic document you can see about moisture during construction with some great design tips on how to mitigate any moisture problems that might arise. You can also see an example of one of many knowledge sheets from our knowledge library. That one's all about using SIPs, but if you delve deep into our knowledge library, you'll find knowledge sheets on all sorts of aspects of timber construction, timber design, best practice, and you name it, you'll find it there. And you can see an example of from our case study library. We have case studies on all sorts of timber buildings, every typology you can think of: domestic, commercial, residential, housing of all kinds. A particular one you can see there is a great example of demountable housing. And if you're interested in the latest developments in sustainable buildings, you'll find examples in our case studies. Here's some information about a new webinar series that we have recently started. This is Timber and Construction 101. It focuses on many technical aspects of timber design. Great way to improve your CPD. If you go to our events page on the TDUK website, you'll see details of all of the new webinars in this series. It's rolling right through from now into 2027, so I urge you to have a look at that. Many of the things we put out in our outputs and webinars like this one are free for anybody to use, but we can't do this without our members. So if you're not a member and you enjoy this webinar, please consider joining us. It gives you access to exclusive member-only content. Most of our knowledge library is only for members. You also get discounts on big events such as the UK Timber Design Conference, which we held last week. So do consider joining us. I'm now going to hand over to Ben, who is going to start introducing today's webinar. Please make use of the Q&A function. If you go down to the bottom, you'll see a little Q&A box. Feel free to type in questions as the webinar progresses, and we'll have time at the end to answer a few of them. So Ben, if you'd like to start sharing your screen, I'll hand over to you. You're currently muted, Ben.
Great. Hi, can you see my screen?
Yep.
Yeah. Great. So we're talking about the Armadillo today. The Armadillo is the low carbon, mobile, demountable mass timber performance base. We believe it's one of the world's first in using a hybrid eucalyptus CLT as an external structure. And I'm Ben Hayes. I'm one of the co-founders and directors of Unknown Works, we're an architecture design research studio based in London. I think the important thing before we go into this project is to kind of frame it. And so this project is really truly a collaborative project. It's an experimental project which is really focused on R&D. And therefore, it's important to kind of frame that within the team and everyone was involved. The most of the time and resource was given in kind in the pursuit of testing and innovating, whether that's from a kind of material science or from manufacture and assembly, design, and also through to sound. And so there's lots of tests, lots of failure, but eventually we had a really successful outcome. So an interesting starting point, therefore, within this framework was coming together with Xilonor CLT and ConstruktCLT, who Jim and Sen are on the call. And we kind of started with a cubic volume of CLT, which is 25 cubic meters. And tried to explore, which then became looking at innovating a hybrid species CLT, which is eucalyptus and pine layered together as a kind of an external structural system. And so from our side, I think we can kind of see this project as the kind of a balance of an intersection of innovating kind of CLT construction methodologies and systems through sustainable forestry. Xilonor CLT are based up in Galicia, and there was a lot of timber and a lot of eucalyptus to utilize. The other was we started thinking about how we could then use this experimentation to explore alternative architectures and temporary cultural spaces, and kind of challenge the norm of how these things are put together, what they're made of, mostly kind of these large steel structures, and think how you could do that in timber in a kind of low carbon alternative. And then layered within that, we also wanted to look at using mass timber to explore an interesting relationship between sound and architecture as well. So as these conversations kind of grew and these certain ideas kind of came out of this intersection of three things, we also spoke to engage with London Festival of Architecture and Houghton Music Festival, which is based in Houghton Estate in North Norfolk. We run a music festival which is very much focused about the quality of sound and experimental sound, experimental structures. And so as a starting point, we started thinking about that, the mechanics of all of these things coming together, developing some sort of architectural formal language in which we could think about a panelized mass timber building, which could be assembled and can be demountable relatively easily, very, very fast within the context of temporary structures and festivals and music environments, but also delivering kind of a kind of exquisite or a unique sound out of that. And so from kind of the architecture side, we're looking at the available cubic meters of CLT, and then thinking about what formal arrangements, how we could achieve this. And what we started exploring was looking at non-amplified sound. So performers within a space that can be surrounded in a mass timber shelter, which can be open to the air, external to the elements. That the structure itself is calibrated to basically project that sound outwards. So negate the need for amplifiers and use unamplified sound, which might be a singular performer, it might be a group, it might be a quartet. And so that's where the kind of the formal language started, thinking about the available sheet sizes that were coming from Xilonor, thinking about how we could nest them to make sure we're zero waste within the cubic volume that we were given. And then also working obviously with ConstruktCLT, how we could assemble that without huge amounts of craneage, thinking about simple prop systems. And then we're also working with Charcoal Blue, who are theatre and acoustic wizards. And they helped us with some of the acoustic modeling to start developing this. And I guess without going into too much detail, what we're trying to achieve is very, very focused sound, a bit like the kind of Dungeness sound mirrors that everyone's probably seen before, to focus that sound onto an area within the crowd. And so there was a lot of testing and prototyping, both digitally and physically, to explore how we might achieve that. And then also in tandem, thinking about the one-to-one scale of how it's made and what Xilonor CLT are able to do with welding these, laminating a hardwood and a softwood together to have an external layer which is weathering and weatherproof, and then the underside which is softer and is coated. Structurally, how we were looking to achieve this also is all of the CLT is structural. So that was the other kind of constraint we set within ourselves. We didn't really want too many additional cladding or superfluous amounts of material. We wanted something which is purely structural, giving the shelter and all the requirements of the brief, but also the kind of sonic behavior as well. So we formed these concentric arches, working with Studio Allen and Arup also helped with some of the engineering for this. And then we sized it accordingly. So on the slide here, you can see the different tones, the different thicknesses and different layers of CLT.
We should just add that just the geometry was very much born out of throwing sound out to the crowd, but also reflecting back into the performers. So there's a lot of, as Ben showed before in the diagrams, so many different iterations of the geometry were born out of making the CLT work both structurally and acoustically. So it's a very hard working system.
And then with that, and I know that Sen will be talking after me just about the manufacture and production process they do at Xilonor, but we also designed these panels so that they could be nested. So all the panels on the left, so the 42 panels on the left, could then also be flipped and be nested within a sheet. So again, minimizing the amount of waste, really working to that 25 cubic meters and see the most that we can get out of it. Structurally, the connections, we also worked with Rotherblast and developed some custom connections. So a big part of this was that it had to be demountable, and it was, and it moved between sites. And so thinking about mechanisms and fixing and plates that can hold the geometry, which is relatively complex. Each arch has its own set of X, Y, and Zs, but also thinking about how we can reuse some of these fixings. We didn't have a huge amount of budget, so a lot of the supply of these materials were in kind, and as I said before, the time was in kind. So, you know, there's probably many ways to do this system. There might be a bolted version to do this system, and within the budget constraints, well, we knew that it was only really going to go to six or seven sites as an experimental structure, and so we developed a screw system which sits within a plate, and it allows for assembly and disassembly. And when these large screws go in, they can go in at different angles, and the plate can move around. So you're not re-entering the same hole on each different site. So it's a kind of a nifty budget way of getting around that, rather than having a fully bolted system, which was unavailable within the realms of this experimental project. And so stainless steel plates were bent and morphed with readings on each of those of which site, which direction the screws should go in, which gave Jim and the team a little bit of headache, but there was a system in place. And Jim will talk about the assembly, so I won't dwell on it. But we had a number of plans of how we might assemble this. Again, we didn't want to have a huge amount of craneage and a huge amount of labor. That was the initial spirit of it. And then some images of the first install at London Festival of Architecture, which was down on Trinity Buoy Wharf on the water. The assembly Jim will go through, but the panels were pre-machined by Xilonor CLT. So try to machine and prefabricate all of the recesses and fixings, drip details, so that we can minimize the amount of work on site. This is in its first install in Trinity Buoy Wharf. We're also dealing with different conditions. So it was a hard, uneven concrete floor, but we also then had to find a way to anchor it down because of the wind uplift, especially on the Thames. And in assembly, it's a beautiful structure that is relatively simple. A lot of work to get there, but it is the structure. The structure is also balanced for the sound. So each of these, I don't know if you can see my cursor on this, but each arch has a slightly different angle. So it's more angled towards the back. And then we use the LFA to explore and experiment. So we have different multi-instrumentalists, gong baths, sound baths, talks. School children, I think, did a choir performance in it. And we then looked at kind of recording that sound. And so we worked with charcoal blue, and we took a lot of recordings to see how it performed. Obviously, if you're performing in different areas of the stage, you get slightly different feedback. The crowd hears slightly different elements. So it became quite a beautiful kind of performative interaction between the listening experience, which is this big wall of sound, because all of that sound bounce off basically projects in about 10 to 15 meters in front of you within the crowd area. So the way to kind of understand it is if you hear it, you're in a room and you're outside, you hear a speaker, it's coming from that point source. If you're in front of it, it feels like it's coming from a surface. And then on to Houghton, very different site, from urban to rural. We found a beautiful spot in the forest, and this is actually where it still remains. We did a lot of photogrammetry to try and find a route in to the forest that all of the panels and tools and machinery could get into, but also somewhere it could fit snug. And it sits at the moment still in Houghton Hall. You can go and see it. It's open, public, available to if you go and visit Houghton Estate. But it also takes a life every year in August for Houghton Music Festival. These photos show the outer layer of the eucalyptus, which is still very, very raw and fresh. Now it's kind of a beautiful silver grey, and the inside is still quite golden in the middle. And we had a lot of live performances, some amplified, some non-amplified. We had spoken word in there, jazz musicians. And the brief for the majority of the performers was just to experiment with it. So if some had speakers, they were turning the speakers back into the structure to focus the sound out. They didn't have the performance were kind of moving around the space and getting a bit more of a kind of interaction with the audience. This is the view from looking inside. The spaces in between all of the arches we lined with a silicon, we call it like a gill, which is your waterproofing layer. So it might, if I go back, it might think like the obvious thing to do is to put the panels the other way around. So the bigger panel sits over the smaller panel, but with the acoustic angles we need, it was impossible to achieve that. So the challenge was then to find a waterproofing system, which you can probably see in a few of the other slides, that you have this silicon gill which sits and is screwed into the edge. There's a rebate which is machined in Xilonor's factory to take that, where you have some LEDs as well. The beautiful, you can see on the inside here, the beautiful thing about that is it allows the sunlight to capture each of these concentric arches. As the sun comes past, you get quite a dynamic kind of lighting condition.
Another thing that was quite a sort of a discovery after being on the site was that the rest of the site is very loud. There's multiple different stages that surround this site, and so noise bleed into this venue was a real issue, especially given the fact that the main roster of artists performing here are, as Ben said, more ambient performers. So the cocoon acted as a shield to shield that sound bleed, and then when you just by facing the structure away from the rest of the other stages, you got this very intimate moment whereby you stepped into the face of the Armadillo, and it was a very focused experience dedicated to that stage alone, and with no other sound bleed coming from other venues.
And then the last few shots before we hand over to Sen was the life it takes at night. So with the sound, we connected the sound to a dynamic lighting setup, both on the outside and the inside, that you can see in these images. which also allowed the spirit of experiment to kind of permeate and go forward with the artists that use it. So the artists can kind of plug into the structure and activate it, not only kind of sonically through how they play the music on it or amplified and move around it, but also with the lighting conditions and that. And so I will stop there and allow Sen to jump in.
Thank
Thank
you.
you, Ben.
You okay to?
Yeah.
Just while Sen's sharing his screen, I'll encourage everyone to make use of the Q&A box again. I see we've got one question there, but do ask your questions.
Okay. Are you seeing my screen?
Yes, that's great.
Okay, brilliant. Yeah, so I'm Sen Perez. I look after Xilonor in the UK, which is the CLT branch of Finsa. That's a Spanish timber materials manufacturer. So I'll just keep it as brief as I can. I'm aware that we don't have a huge amount of time. So I'll just talk a little bit about the background, Finsa, Xilonor, the timber that we use, particularly for the CLT. Very briefly, what is CLT, just for the benefit of anybody who's not familiar with it? We often assume everybody's completely on board with CLT, and it's not always the case. A little bit about the spark for this project being the LFA, London Festival of Architecture, and then just touch on how this was a really great opportunity for R&D for Xilonor and for everybody involved. So yeah, Finsa, as I mentioned, is a timber materials manufacturer based in northwestern Spain. People often think Spain as being quite a barren landscape, but if you go up to the north, up in this northwest corner, you can see on the map, it's actually very green. There's a lot of rainfall in that area, so hence there's a lot of trees. So that's where Finsa is headquartered, and that's where Xilonor, the CLT factory, is also based. Yeah, there's about, well, there's actually over half of all timber that comes out of Spain comes from just that small region. And it's one of the larger forestry industries within Europe. So in terms of the timber, specifically looking at what we use for the CLT as a whole, it's maritime Pinaster pine and radiata pine. That's primarily what is used at the factory. The reason being it's very fast growing. It can be between 20 and 40 years for the growth cycle on those trees. And yeah, it's a project to add value to this local resource, which traditionally has not really been used in any particularly valuable way. So hence the CLT factory. As Ben mentioned, there's an abundance of eucalyptus also in this region, for better or worse. So this was introduced in the 1800s, and then it was heavily promoted through the middle of last century. It was very much state promoted. So it ended up taking up a lot of the rural space, and it actually reached the point where it's a bit of a problem. It's in such abundance, it's such a fast growing species, that in some cases it's not ideal. So to find a good use for this material is very interesting for the region. And then beyond eucalyptus, you've got other species. You've got a bit of spruce, Douglas fir, and then of course you've got oak, other hardwoods. So just very quickly, for the benefit of anyone who's not familiar with CLT, cross-laminated timber, it's basically a means of producing large format timber slabs. So the first layer will be laid longitudinally, let's say. The next layer will be crisscross, so it's at 90 degrees. If you think of it as giant-sized plywood, essentially, the difference being that each layer might be between 20 and 40 millimeters of pine planks. So yeah, we can produce large uniform slabs, and we eliminate any sort of disadvantages that you generally would get with a softwood timber, such as twisting, warping, splitting. By crisscrossing it, you sort of you lock the panels together to create those large slabs. And with those slabs, primarily it's used for construction. So it goes into walls, into floors, roofs. This is just a quick overview of what Xilonor produces. So that would be the master panel in the top right there. Maximum length is 12 meters, maximum width of 3 meters. So that's the master panel. We can cut from that whichever size or shape we need. And in terms of thickness, it runs from 60 millimeters. So that would be 3 layers of 20 millimeter planks, right up to 300 millimeters and beyond. Yeah, and then as is the case with most CLT manufacturers, there are various visual grades. So it runs from non-visual, where we allow natural defects, knots, sap pockets, and then later on, it would be expected that that wood will be probably covered using plasterboard or other materials. We've got an industrial grade, which is basically in between. There's a lot less knots, a lot less defects. It might be used for small warehouses or sports centers, that kind of thing. And then the visual grade is the highest premium grade. In the case of Xilonor, there are very few knots, if any. And that might be used in high-end domestic settings or offices. So with those slabs, as I say, we can produce any kind of shape or size. And there's actually 2 large CNC beds at the factory. So the slabs are laid on the bed. We then cut it to the size required. We can cut out the doors or windows or any drill holes or grooves, half laps that may need to be produced. And then with that, we hand it over to Jim a lot of the time, and he can assemble it with his wizardry using the crane, and it's put into the complete structure. So that's just for anyone who's not familiar with CLT. Lots of possibilities. As I say, it comes off of a CNC bed. So in terms of the shapes and structures and options, it's almost wherever your imagination can lead you within reason. So there's an example on the left here of a tessellated roof structure, which is, to do that by any other means would be really complicated. There's a stairway that was produced using CLT. We can do, furniture pieces, other structures. Just one other point with Xilonor is being part of Finsa. In Finsa UK, we bring across about 3 vessels each month into Birkenhead. So this is the means of transport that we use at Xilonor, meaning much lower cost, lower emissions if you compare it to the equivalent amount of lorries. And we can also cater for smaller projects. So if you just need, say, 5 cubic meters to build an extension or a garden room, you don't have to cover the cost of a full wagon crossing Europe. We just would charge for the space on the ship. Customs is then handled by Finsa UK, and we can put it onto any size sort of onward transport. So just onto the origin of the project, I guess. Finsa's taken part in the LFA London Festival of Architecture for a few years off and on now. Usually in the capacity of the decorative panels side. Finsa produces all kinds of melamines and MDFs and all that kind of thing. So there's a lot of interest among interior designers and architects. This year, 2024, we decided to put all of the focus on the construction materials and really focus on the CLT. So we decided to set a limit of 25 cubic meters of CLT and see where we could go with it. So it was a really good opportunity where we're not tied to any of the constraints of any building regulations, or it was also a temporary structure. So we didn't really have to be too concerned, obviously, about the usual constraints, which really let us experiment. And I think it's been a great experience for everyone. It still remains something that we're tracking and we can see, and everybody else can sort of take a look at. And so, yeah, it's an interesting, really interesting project. This is just a very quick list of CLT advantages. I'm sure most of you are familiar with that. And typically, CLT would be the structural element of a building to then be clad with an exterior material, whatever that may be. Typically, it wouldn't be exposed to the elements. It's kind of rule number one. So, as I say, in this case, we weren't tied to that constraint, and we were able to play around quite a lot and see how far we could push it. The first idea that we had was to look at the cladding that Finsa manufactures, which is a thermally modified pine. So this is basically slats of timber which are cooked. So the process, rather than pressure treating or adding any chemicals or using hardwoods, in this case, it's basically heated up to 220 degrees. And that in itself changes the cellular structure of the timber. So there's no chemicals added. It makes it a lot less hygroscopic, so it's able to withstand being exposed to the elements for a long, long time. The issue with this was it introduced a whole new level of complexity. The guys at Unknown Works were looking at an exterior structure on top of the CLT, and it became very, very difficult, and also the cost started to spiral. And that was where we started to look at the option of eucalyptus, given that this is such an abundant resource in northwestern Spain. It's something that Finsa has worked with in the past, not necessarily in this context at all. And so we started to explore the possibility of creating a CLT slab where the exterior layer was actually using eucalyptus, which is a more durable timber. So it's going to resist the elements better than the pine. It's also a much harder and robust wood species. So this ended up being the avenue that we went down. So it meant that we had a much more straightforward, well, in inverted commas, a much more straightforward structure. It eliminated lots and lots of parts, and yeah, it's interesting to see how it turned out and to see how it's still holding up to this day. So yeah, that's pretty much all I've got for you today. I'll hand over to Jim, who can go into a lot more detail. He went through much more of the pain of actually making it a reality and putting it together. So I'll hand you over to Jim.
The joy of going last on one of these things is that quite often everything you were going to say has already been said. So the might be a bit of repetition going on, but bear with me. So this is what 25 cubic meters of CLT looks like on a lorry. It's arriving from Birkenhead on day one, and we had a 60-ton crane to unload. We used a bigger crane because we were going to be reaching further with the full-size packs. So we reduced the crane once we got into construction, and so then we get the construction phase. It's quite a small palette of material of fixings, really, although it seems very complicated. It was the alu start rail at the bottom. We've got the VGS screws and the washers, and then cables to restrain the bottom of the panels, which I'll sort of go into in a little bit. So setting out was key. You know, it's a complicated shape, so you can't just start drawing lines on the floor and hoping that it's going to go together. So we used the total station to set the alu start rails out. So we used GPS for that, and we had to deal with quite a lot of height difference where we were at Trinity Buoy Wharf, because it's basically a car park, and you can see we had curbs and all sorts of, sort of things to deal with. So we had a height difference of 222 millimeters between the highest point and the lowest point. So that took quite a bit of dealing with. We bolted the alu start down, and then once the first run of panels were in, we cast concrete upstands underneath. So yeah, we go to the next one. So there's your alu start bolted down and everything set out, and you can see some of the height difference, how far curbs that we were getting over and so on. So we then had all the panels are numbered, as you saw from the nesting. So every panel is identified, and every panel was packed in sequence. So we didn't start opening packs to find a panel that we didn't need and so on. So everything was sequenced to allow us to build it as quickly as possible. And as Ben showed earlier, we had a few sort of versions of how it would go together. But as happens with most of these things, once you get into the build stage, you sort of go a little bit off-piste, because you're trying to reach, or you're trying to get machines in, or you're dealing with an awful lot of propping, and so on. So some of these things change, but pretty much this is how it went together. And see where the environment that we were working in, it's a nice place right on the Thames. Very proud of where we are. You see the cable car in the background. so we used that to get some pictures later. And so this is panels going together, propping. So different size props for different panels. As we got higher and higher, so the props got bigger and bigger. And there we go again. Now, something I was going to mention, the screws that we used, the VGSs, there's been a comment earlier about how are they held in, how do we keep the angle? So the washer is the key to that, the 45-degree washer, and that is set within the ellipse on the plate, and that then guides the screw in on the angle that we need. There we go. That's the washer in place with the plate. I think that one says A6 on it, so we had identified everywhere, as well as having the 1, 2 on the, so that we could identify the angle or the direction of the screw. So first install and second install, so that, as Ben said earlier, we weren't chewing into old holes. So so the screws then had fresh timber to bite into. This one is A6, and that we were told we would work out exactly where that went. The yeah, so another shot of the same thing. Here we go. So we then, as I say, went a little bit off-piste, and rather than going all the way down with the third row, we realised that that was going to be quite heavy, and that would be then relying purely on props holding it up. So we decided to complete each arch, and so work with the keystone effect of putting in the top one and locking the arch into position. Ben made a comment about the fact that it's sort of backwards. That was quite a challenge, to be building what would normally be the overarch under. So we sort of had to think about it in a slightly different way when we came to propping and installing, which was again another little challenge. This whole project was all about challenges and meeting them, and I think between all of the people involved, we certainly did that. But it's quite a simple. It's the CLT working and the connection detail that it's all about. Everything else is it's not as complicated as it might look in reality. So it's quite a bit of propping. So this is from the cable car, as we see it, as we went over the top to look back at Trinity Buoy Wharf where it was sitting. Yeah, and you can see that the SS Robin, the Trinity Buoy Wharf is an interesting place because it's all about businesses that are based around design, engineering. So the lighthouse there is where Faraday tested his light bulbs. The school on the corner there's Faraday School. So Michael Faraday invented the light bulb here. So it's been a place for R&D and for this type of work. So I think we fitted in very nicely. There we go. Oh, I seem to have stopped. Wait a minute. There we go. So this is it in its finished iteration with the staging. We can't see there is the cables that run across the bottom. There are quite strong forces on at the top. I think it's about 10 kilonewtons, and halfway down it's about 4 kilonewtons of force in like a moment connection. And then the cabling across is what stops the building pushing out. We can't, because here we couldn't go deep with the foundation because we're working on a car park. We had to work with something in a slightly different way. There's a little video, it's only a minute, so hang on, I'll just turn the sound off. You get a feel for how simply the panels go together, how accurately they've been cut, and that creates the angle. So we just used the natural form of it to create each angle. We did think about putting register marks on the floor where that should be if it was vertical and so on, but it just seemed easier and more correct to just follow the form of it and let it get itself into position, which it did quite nicely. So that's that little video. So then the final structure, as it was ready for the LFA, the stages, it was used during its 4 weeks at Trinity Buoy Wharf. It was used for weddings. The local school put on their end of year show there. We had our LFA presentation. There was a couple of smaller ones that we did. But generally, it was visited by a fair few number of people. It seemed to be well received within the wharf, and became quite a feature. It was sad to see it go, to be honest with you. But it was only there for 4 weeks, and as is usual, when you're borrowing somebody's space, you get to the end of 4 weeks or the time you're allowed there, they want you gone. So we had to work hard to get it taken down. It's just the last couple of the nighttime shots with a dome in the background. The LFA event, Ben's already mentioned. We did a presentation. We all spoke about what we did, and then the demount started. So taking it apart, we didn't break it down into complete individual panels. We realized that, we had these sections that we could take apart and leave them connected. So for speed of demount and for ease of reusing fixings and so on, we decided to work in a slightly different way. So as it came down, it was in like 2s and 3s as opposed to single sections, which we then loaded onto the lorry for its journey back up to Norfolk. Which the reassemble was fairly simple. I thought obviously getting in was key, but we used a HIAB, and so the HIAB travelled up and down the trackway, bringing the panels into where it was going to work, and then installing what was on the back of it, and then going back and getting some more. So it was very efficient way of getting the panels into site. Here at the site, they had the opportunity to put concrete in ground for the footings, so it's a slightly different system, but it still has the alu start, and the cables were still used on these block up stands. And there it is as we've finishing the install. You see the high ab lorry in the background, fewer props, but yeah, ready to go, moved. And then the Houghton Festival itself, which my daughter's been to, my goddaughter's been to, and the family are all sort of visiting it every year, so it's become a bit of a tradition in our house. There we go, thank you very much.
Great, thank you, Jim, and to all the other panelists. Yeah, so let's crack straight on with the questions. Yeah, we had a couple of questions about the installation, and Jim, you've actually given us quite a lot of information about that. But I wondered if anybody could say a little bit more about how the Armadillo was anchored. Somebody had asked how it was anchored on both the London and Holston sites. You know, perhaps you could say, I think, Jim, you mentioned like cabling, and you mentioned the alu start. So yeah, if anybody wants to pitch in on that. So
at Trinity Buoy Wharf, we used resin anchors, and we bolted down through the alu start so that we could then, when it was demounted, we could take the alu start straight off because it was only bolted on, and reuse it at Houghton. And then we could just cut the bolts and leave as sort of a smaller footprint as possible at the wharf. You know, the idea was to have a very light touch.
Great, thank you very much. And I suppose a related question, somebody had asked how you maintain the required angle when inserting the screws.
It comes down to these. Okay. Basically, you have a washer with a 45-degree angle on it, and the screw going through it. It fits very snugly, and it takes it through on the 45 degrees. So that's how you maintain the angle.
Great, thanks very much. We also had a couple of questions about treatment, and I guess specifically about moisture. You know, how was the wood treated in general and specifically at the edges from a waterproofing perspective? I guess we could also ask about, you know, runoff and the angles. Might be relevant, but yeah, a sort of treatment question.
Yeah,
you go first.
Just to say a big part of that obviously was in the design itself. So wherever possible, we would angle everything so that any rain would just run straight off. There was no nooks or crannies where you would get accumulations of water. So that was pretty fundamental, I guess, to the design, which the other guys can probably elaborate a bit more on. In terms of edge treatment, we did apply a waterproof edge sealant. Obviously, that's the most vulnerable part of CLT because you've got the end grain, and that's where it's going to suck in the most amount of timber. So we did apply an edge sealant to that to prevent water being absorbed.
I think the way we saw the whole structure is a piece of external joinery, and like with any timber structures, it does have movement, and so obviously the design has accommodated for that expansion and compression over time. But from a perspective of sealing it, we sealed it with, you know, Rubio monocoat. I think it was like an oil. Ben and I were up there 6 meters high up with harnesses, finishing the whole structure. And there is a level of care and maintenance that actually does need to take place. Not that much, but you know, as with any you know, outdoor piece of furniture or joinery, you know, it does need a bit of care over the years. But I think as Ben was mentioned before about the eucalyptus layer, that serves as a major protective layer, forming the shield to the rest of the CLT. And that's very much part of the pioneering aspect of this project.
It's funny how the questions prompt you to remember something. The top edge of the panels were machined so that on that leading edge, it was only the eucalyptus. There was a step, and then your silicon membrane that was creating the gill went up underneath that. So the only exposed edge on the leading edge was eucalyptus, and not the pine and not the end grain. So there were some quite clever little nuances that were done to protect it from moisture, which actually probably just get forgotten almost. And also during this time at LFA, we had the Tector sensors on it to read the moisture at the back of the eucalyptus. So we drilled through with the prongs and set them to just behind the eucalyptus, and then monitored the moisture readings. And it never went beyond the factory levels, so it was protecting the pine perfectly.
Great, thanks. I'm going to see if I can combine two questions. One question had asked about the screw holes, and then at the second installation, and the question had asked, how do you ensure the first screw holes are not used at second installation? But I suppose elaborating on that, do you use the same holes for the second installation, and are there things to bear in mind? Do you have to use, I guess, wider screws for the second installation to take account of the fact that those holes might be a bit bigger? And somebody else had asked, are there limits to how many times the structure can be reused if the bolts require fresh timber for connection? I'm not sure if the bolts do require fresh timber connection, but
I think we also on the slide we showed these folded stainless steel plates, folded stainless steel plate which is bent at an angle, and that's kind of repeated across, connecting all of the panels together. That then sits within a slightly recessed groove, which is machined within the eucalyptus layer, which is oversized. And I think you remember if you saw on the slide, we have basically numbers on each of the holes, and each of those numbers corresponds to alternating sites. Site 1, you screw in to make sure it's in the direction of 1. When it moves to site 2, you do it the other way. So the screw will never re-enter the same hole. That's for 2 sites. We designed it for 6 sites. And so the oversized plate within the groove, the oversized groove where these folded plates sit, can shift up by 20 or 30 mil, and you can do it all again. So there was a kind of quite a nifty system that we kind of worked up. It only went to 2 sites because the second site was so successful that Hudson wanted to keep it. It may be in future, it might be moved again. So I think there was just an interesting way around it. Ideally, for an external structure, I think that is traveling, and we're working on a few others, to multiple sites, you really want to have a kind of a metal to metal connection. You want to bolt it. But we were working within the constraints of the tight budget, but also we kind of knew that it wasn't endlessly going to travel. It was essentially only going for 3 or 4 sites.
Thank you. Couple of other questions. Are the joints between each panel tongue and grooved? And I think there was another question that was maybe in a sort of similar area. Well, let's just stick with that one for the time being.
No,
they were just butt jointed.
Yeah. Okay. Butt jointed. Right.
We could design them with a half lap, or we could design, but all of that didn't seem necessary in this instance.
The beauty actually is that the structure stands up with if you cut the joints at the right angle, which the guys did very, very well, very accurately, that you don't need any additional detailing with the joinery, with the jointing there.
Are the panels the same thickness, all the way back?
No, so they changed. thicker on the largest, and then they're the size they need to be structurally. So as you work back to the smaller arches, you get less thick CLT panels. So
also the plates change size as well. So they're like 4 screws or 6, whatever. And as the panels get bigger, so the plates get bigger, and there's more screws in the connection. As it gets higher up, the flatter the arch, the more force there is.
Somebody has just asked about the structural function of the blocking between the arches. Would anybody ever be able to say anything about that?
Yeah, so I mean, the arches are doing all the primary structure, so they're kind of self-supporting. The blocking between them, it's a good question, is merely connecting them together. It does provide a bit more kind of, I guess, a lateral support, but the structure, the arches themselves are kind of self-supporting, and then it connects them together, basically.
Interesting question. Could this be scaled up? Could the same design effectively just be made larger for bigger audiences?
Please.
It was larger at one point. It was, I mean, I don't see why not. I mean, it'd be good to have Toby, the structural engineer, on the call for this question. But yeah, I think at one point it was engineered as something larger. We're working within the CLT panel sizes. So they come off the press and the bed from Xilonor CLT at a certain width. And so that would be really, firstly, that would be the defining if you want to do it within one panel. That fits, that can nest perfectly within a sheet of raw CLT. But I think as long as you have the structure, it can be scaled up. To what extent, I'm not best to say.
I think what you end up with is probably in the biggest arch, you probably end up with more elaborate kind of stitchings between the panels, because that's the bit that will inevitably hold the structure from collapsing in on itself or splaying at the bottom. But yeah, I mean, structurally, you just have to be a bit more elaborate, I suppose.
I was wondering how the sort of acoustic design was handled. Was a lot of that coming from, I think the name was charcoal blue, were mentioned earlier, but just in terms of the I suppose choice of material, size of pattern, position of panels. What was there a acoustic sound design consultant specialist sort of involved in that?
Yeah, so charcoal blue, who they work on pretty much all the major theatre projects in and around the UK, but they also have kind of specialisms within acoustics. So Luca Della Torre was working on the project. And we knew from the outset, said in the beginning of our presentation, that we knew it was going to be some sort of demountable space. We anchored on the fact that we wanted this to be some sort of culture space, which dealt with sound, and so they brought on quite early. And it was a very dynamic, just kind of development of a kind of a shared model. So we were using various scripts back and forward to develop the form, and then they were then looking at the acoustics and running various scripts to test the acoustics, where the sound was converging, what type of issues we might perceive. And so I think for quite a few weeks and maybe months, it was kind of going back and forward, and then shared with the rest of the team on the call too, then looking at the viability of the material and how we might fix that. So I'd say it's a very dynamic exercise, but yeah, it was all acoustically modeled and scripted to make sure that we achieved what we wanted to achieve. And then when they did the testing, they tested with microphones and popping balloons, the way to do it, to test the kind of reverb and echo. They did that in the London Festival Architecture at Finsbury Wharf, and then they also did it in Houghton. The results were obviously slightly different because Houghton was in the forest, so kind of acoustically optimized in that scenario. There was background noise from the festival, but when there's not the festival, it's pretty quiet. It's mostly bird song that kind of gets amplified. but it performed as expected, which was fantastic.
And the fact that it was timber actually benefited the sound reflection. You didn't get very sharp reflective or any dissonance. If it was metal panel, it would have been a lot more. It would have registered the higher sort of frequencies a lot more. So the acoustic mass of timber, it actually benefited the design of the acoustic environment underneath it.
That's good to know. We've overrun slightly, but I think I'm just going to ask one more question. Now, we've already spoken about the cabling, but somebody's just asked for a little bit more detail about the cabling. How the cabling functioned in order to restrain the panels. If anybody could elaborate a bit more about that.
The cabling connects Jim installed it, so he can talk about the installation side, but the arch is obviously a very robust, rigid structural form. But and so a lot of the weight on the joints, we're talking about where the joints are rebated, there's a lot of pressure on the top of those joints to when the panels are put together. But there is a natural urge for it to splay out. So the cables are tying the base feet, let's say the base panels, across to one another, just to ensure that that it wouldn't splay out with any kind of external extra force onto it. So in the LFA, Tridgeway Wharf, they were above ground, connecting the Alistrat, which are the aluminium channels, and then for the Houghton install, all of the fixings, all of those fixings, they're all kind of maritime base, stainless steel grade, and they were buried underground. So they sit on the underside, and then that's all been barked over. But they're just there if there was any additional movement to stop it from splaying.
Yeah, just purely as restraint.
Okay, great. Well, I think we're going to have to wrap it up there. So thanks again to the panel.